Hello friends, how are you all doing? Hope you're enjoying our series of videos. In this video, let me start with an interesting question. In a class of students, there are 5 students who like playing football and there are 6 students who like playing tennis. Can you tell me what is the total number of students in the class? The obvious answer would be 11. But what if I say that the class has only 9 students or even 8 students? Puzzled? So to answer this question, let me take you back in time to 1880. Can you see this man on screen? He's a famous logician, philosopher and a teacher, John Venn. And this story dates back to 1880 when John Venn was there in Cambridge, England, and he was interacting with a group of 9 students. He asked the students to submit a list of those who liked playing football and those who liked playing cricket. And astonishingly, he got a list of 6 students for football and 5 for cricket. He was puzzled because in all there were 9 students in the class, but the list showed 6 plus 5, that is 11 students. But on careful examination, he understood the mystery. The point was, there were 2 names in the list, Jack and William, which were repeated in both the lists. That is, their names were there in the cricket list as well as the football list. And that's what was the reason for those 2 extra numbers. And this guy thought that if this question could puzzle him, the same would happen with other people also. So why not put this concept in the form of a picture or a diagram which makes things easy for people? And this is what he did. He took 2 circles like these. The first circle would represent those students who like cricket, and the second would represent those who like football. Now, he overlapped the 2 circles partially like this. Then he put those students who liked only cricket there and those who liked only football there. Now only 2 students were left, Jack and William. Now as we know that Jack and William had given their names for both the sports, he put Jack and William in the middle. Why in the middle? Because can you see that is the area which is common to both the circles, and as you know both of them like both the sports, they were to be in the middle. Here the first circle represents those students who like playing cricket and the second circle represents those students who like playing football. There are 2 very important concepts to be learned here. One is intersection. Intersection is nothing but the common area between the 2 circles. That is, the area where Jack and William are there is called the intersection of the 2 circles, and it is represented by an inverted U. The symbol looks something like that. The second concept to be learned here is union. Union is nothing but it counts all the people inside the 2 circles. That is, all the 9 people taken together would be the union. And union is represented by a U. The 2 circles that we just saw are technically called sets. A set is nothing but a collection of things or objects which share some common property. Like the first circle in the previous question talked about students who like playing cricket. So that's a set of students who like cricket. The second was a set of students who like playing football. Similarly, you can make sets of anything. All men could be put under one set, all women can be put in a set, all students can be put in a set, all animals, birds, different type of sports, everything can be represented in form of circles called sets. Now, on the basis of these sets, a lot of questions are asked in your competitive exams. Now let's see how to go about it, what are the concepts and what are the different types of questions that are asked in the exams. So now let's talk about sets and relationship between different sets, how they are represented diagrammatically. So basically there are 3 basic concepts. 1, the all relation. 2, the some relation, and 3, the no relation. So let's start with the first one, that is the all relation. Suppose I say that all A are B. That will be represented something like this. Here the set that represents A would come inside the set that represents B, because in this diagram you can see that the complete area under set A is a part of the set B. So we can say that all A are B. Similarly, say I take another example. If I say that all boys are human beings, it will be represented something like this. The set representing boys would come inside the set that represents human beings. But there is something worth noting here. All boys are human beings, but all human beings are not boys. Please remember that. And that can be proved something like this. Can you see that point there in the human beings set? Is that a part of the boys set? No, right? So we can definitely say that here all human beings are not boys. Now suppose I say some A are B. That will be represented by this diagram. The first set represents A, the second represents B, and there is some common portion between the two. We can take one more example to understand it better. Say I take an example, some men are teachers. It can be represented something like this. Here, the first circle represents men, the second circle represents teachers, and the common area you see in between the two circles, that represents those men who are teachers. It's worth noting here that not all men are teachers. These men are not teachers. Only the men in the middle are teachers. Next concept, if I say no A is B, it will be represented something like this. Here we have two distinct circles, that of A and B, with no common area between them. We can take another example. Say if I say no men are women. This can be represented by two different circles which have no common area, because obviously men are different from women. Now let's start with type 1 questions. On screen you can see two columns, column A and column B. Column A consists some words and column B consists of some diagrams. You have to match the right set of words with the right diagram. So let's start with the first one. Doctors, engineers and lawyers. Which diagram would represent them? See, doctors, engineers and lawyers, all three are different professions. They do not have anything common between them. So obviously, these will be represented by this diagram. Second, day, week, year. See, days are a part of a week and a number of weeks are a part of a year. So, days would come inside weeks and weeks would come inside years. So, that would be represented by this diagram. Next, tables, chairs and furniture. We know that all tables are a part of furniture. Also, all chairs are a part of furniture. So, tables and chairs should come inside furniture. But is there anything common between a table and a chair? Nothing. So, they will be two separate sets. So, table, chair and furniture will be represented by this diagram. And lastly, boys, students and human beings. We know that all boys are humans. Also, all students are humans. And between boys and students, obviously, some boys are students. Maybe some other boys, who are not going to school are not students. So that will be represented by this set. Question number 2. Again, we have some words on the left side column and some diagrams on the right side column. We have to match them. So let's go to the first set of words. Dogs, pets and cats. These words can be represented by this diagram. Why? Because, see here there are three circles. The center circle represents pets, the left one represents dogs and the right one represents cats. Now we know that some pets are dogs. So there is an interaction between the set of pets and dogs. Similarly, some pets can also be cats. So there is a common area between pets and cats as well. But as no dogs can be cats, those two sets are completely different. Question number 2. Boys, students, singers. This can be represented by this figure. Now why? Basically, some boys can be students, some of them may not be, say they're not going to school. Similarly, some boys can be singers. Not every boy is a singer, some boys can be singers. And similarly, some students can also be singers, right? So basically, all these three sets are interacting with each other, which is shown by this figure. Next one, engineers, human beings, rats. All engineers are human beings, but no human being is a rat. So that can be represented by this figure. Here, there are two circles, one smaller circle and the bigger circle. The smaller circle represents engineers and the bigger circle inside which it is placed represents human beings. And the set which is completely different, like away from the other two sets, represents rats. The last question, females, mothers, doctors, is represented by this figure. All mothers are females and some mothers can be doctors. So far, we've seen that Venn diagrams are generally represented by circles, but not necessarily every time a Venn diagram has to be represented by circles. It can be represented by other figures also, like it can be represented by triangles, rectangles, squares, pentagons, and any other figure. So let's take a question to understand this concept better. Now, on screen, you have a complicated figure which is made up of three figures. First, it has a rectangle, and the rectangle represents those people who love playing tennis. Second, we have a circle. The circle represents all those people who love playing football. Third, we have a triangle. The triangle represents all those people who love playing basketball. And you can see some numbers also on screen. These numbers represent the respective number of people, those who play those sports. For example, if I ask you, how many people play football? The answer would be everything inside the circle has to be added, like 8 plus 7 plus 4 plus 5. The answer would be 24. So 24 people play football. Similarly, if I ask you how many people play tennis, you have to add everything up inside the rectangle. And for basketball, you have to add everything up inside the triangle. Next, if I ask you how many people play only football, now always remember in Venn diagrams that word only has got an importance. Whenever they say only football, you have to consider only that area which falls under football and under no other sport. So you have to look here at that area which is a part of the circle but not a part of any other figure. So we have these 8 people who play only football. Next, how many of them play football and tennis? The word "and" is very important and is an important concept in Venn diagrams. And basically talks about the common area between the figures or the intersection. So football and tennis means the common area between the circle and the rectangle. And your answer would be 4 plus 5, that is 9. Next, how many students play football and tennis but not basketball? Now that's a tricky one. So let's try to break the question down into smaller parts. First, let's read the first part of the question, football and tennis. As we did in the last question, football and tennis represents this area. Then the question says, but not basketball. That means you have to remove that part of this area which falls under basketball. That is, you have to remove that area which falls under the triangle. So this area would be removed and you are left only with this area. So the final answer is 5. Next question. How many people play all the 3 sports? All the 3 basically means you have to look for that area which is a part of all the 3 figures. And as we can clearly see, these 4 people play all the 3 sports because this is the area common to all the 3 figures. And the last question, how many students play football or tennis? Now we have got a concept here. Or always means you have to look, you have to take the union of the figures. That is, football or tennis means you have to take all these areas. So your answer would be 8 plus 7 plus 4 plus 5 plus 2 plus 3. So the final answer is 29. So 29 people play football or tennis.